Hello, this is Mr. Kent of MrKent.com. And yesterday I was thinking, I think I'm going to take my drone to the park because the little draw that I fly up and down in my favorite park has got a lot of green foliage in it. And our temperatures are getting up to over 100 degrees, 107, 110, and so forth. And that's all going to be gone. And I kind of wanted to get a picture of it, but I think probably my viewers are getting tired of flying up and down that little draw and saying I'm getting tired of going out in the heat. So I thought, well, you know what? I think what I'll do today is just put together some information and see if I can help some guys understand things a little better about radio signals coming out of different transmitters and so forth. Now this is a DX6 spectrum transmitter. This is what I use to fly my model airplanes with. Excuse me, I'm sorry. Shouldn't be doing that. And this is the transmitter for my Mavic 2 Zoom. And you'll notice one's bigger than the other, but they're both about the same power output. This one is just easier to hold on to and so forth. Anyway, we're going to talk about these transmitters today, and I'm going to try to help everybody understand. Some people already do, I'm sure, but I'm going to try to help everybody understand why radio signals do the crazy things they do. So let me get a piece of paper here, and I'll lay it down and start from the beginning. First of all, let me explain. I love teaching electronics. I taught electronics for many years, and I have my first class commercial license, which really you don't need anymore, but I needed it back in the 70s when I got it. And then I have my amateur extra radio license. So it's not like I don't know anything. The problem is I've forgotten everything. So let me see if I can get started, first of all. The first thing before I can even begin talking about transmitters and receivers is we need to understand how a radio wave works. So let's say that we have a vertical antenna. That's my cut-off finger. Got cut off in a lawnmower when I was a kid because I'm dumb. Anyway, so you put up a vertical antenna, which is what those are kind of like that. Anyway, you put up a vertical antenna, and it radiates a signal out, okay? And that radiates that signal out, and then that signal comes across the receiver antenna of like on your drone or something, and it picks up that signal. And so let's pretend that we have, let's see, I'll use this because it's easier. I got lots of paper. Let's say that this is our radio antenna. We're looking down on the radio antenna, okay? And first of all, I need to explain that when you start working with signals, radio signals, you have to back up and learn a little bit. Your house current, like in Europe, the house current is 50 cycles every second. In other words, so let's just start here. So it goes like this, okay? And it does that 50 times every second. In the United States, ours does it 60 times a second. So they're closer together because you got to cram more into 1 second, okay? So this would be called a higher frequency than this because this happens more frequent, okay? And what happens is on that radio antenna, let's put that over there, and let's go over here and get another piece of paper. On that radio antenna, what they do is, here's the ground, and here's the antenna, and here's the guy on the transmitter. It sends a signal up the antenna and down the antenna, and that's called 1 cycle, and or 1 hertz, they also call it that. And so in a radio signal, you have to get up over, about 2,500 hertz, or 2,500 times per second, before anything will start radiating off of that antenna, okay? So like the house current isn't going to radiate at 60 cycles per second or 50 cycles per second. It has to get up over 2,500 hertz before anything starts coming off of the antenna. Now, here in the United States, we have what we call the AM frequency, and it is from 535,000 hertz up to I think it's 1605. And what they do is they take that off and they say 535 KHZ, or kilohertz, okay? So that's the AM broadcast band here in the United States. The FM broadcast band, first of all, let's talk about what is AM. AM stands for amplitude modulation. In other words, if I was transmitting over the radio my voice, things like this, okay, they would directly, these pulses, higher in level, would increase and decrease the power output from the radio, okay? That's amplitude modulation. Frequency modulation is my voice would, as it goes louder and softer, it would modulate the frequency, okay, or change the frequency. So that's frequency modulation. The nice thing about frequency modulation is you like if you're listening to your favorite musical piece, there's no other station is going to interfere because it's not on the same frequency. Whereas in amplitude modulation, another station can be on the same frequency and it'll come right in and overmodulate or override the other signal. Now, there's a good thing about this because, like, if you're talking to the tower and you're in your airplane, and here's the tower, and you're here, and you're talking to the tower, and there's a guy out here, and he has troubles, okay? When he starts talking, the guy in the tower is going to hear us both at the same time. And when he hears this guy say, "Mayday, Mayday," he's going to tell me, "Be quiet." And then he's going to listen. So you can get two signals at the same time, and that's why aircraft use the amplitude modulation so they can hear more than one plane at a time. But frequency modulation makes it real hard for another station to interfere because they're modulating at a different frequency at a long time. Make a long story short, there's your amplitude modulation and frequency modulation, okay, and the difference between the two. And in the United States, the FM band is actually at a much higher frequency than this. It is from 88 to 108 megahertz. In other words, 88, that many cycles per second, okay? And so it's a much higher frequency. And one thing I don't have time to go into, but these lower frequencies bounce off the ionosphere. Let me just show you something here real quick. I don't want to take too much time on that. But here's the globe. And we have the ionosphere around up there. That's the ions where the sun hits the electrons in the air and knocks the electrons off of the protons. And so then you have what's called an ion. And so these radio signals have a hard time going through there, so they go up like this and they bounce down, so you can talk to somebody way far away. All right, so let's just put that over there. Let's get another one here. Okay, so higher frequencies, let's go back. Let's get this guy back. Higher frequencies, they don't bounce off. They just go through it. Okay, the higher the frequency, the more they go through it. The lower the frequency, and it's not like exactly a division point. In fact, it changes from time to time. But we don't want to get into that. So, okay, so now you know a little bit more about radio frequencies, I hope, okay? So, let's talk about the antenna again. Here's the antenna, and it's radiating out, okay? Right next to the, let's say our antenna picks up bananas. We'll call it bananas instead of frequencies, okay? So if we're right next to the, I'll put some graphics on the screen too. If we're right next to the antenna, if we live right next to it, we get one banana every time it transmits, okay? But as we go out away from the antenna, let's go out to here, okay? So this one banana that you would get right next to it has to be split up between everybody that's out here. And so as it gets further away, let's say that, let's say we get 10 bananas out here, okay? So, because you have to split up you get 1/10 of the banana, okay? And if we double that, Now we really have to divide that banana down. And if you double it, you multiply, this would be like I think 1/40th. I don't remember all the details now. And if you go further out, it's 10 times 40, or 1/400th. Anyway, it's roughly like that. The further you get away from the antenna, the less banana you get, okay? So these guys out here don't get near as much banana as the guys that live right next to the antenna. And so that's called signal strength. As it gets out, that one signal, that banana signal, has to be divided up more and more and more as it gets further from the antenna. So that's why when you're out and you're out in the desert, and you're like when I go out flying in the desert, and here I am, and my drone's here, and I have a good signal, and it's here, and I have a good signal, and it's going out, and finally when it gets way, way out, it doesn't get enough bananas, so it starts saying, I'm starving out here, and then it just doesn't have enough to make the drone do what you want it to do. And so they've got built-in return to home, and so it says, I'm going home. It says, I'm going to go where the bananas are. So he turns around and comes back. But here's the problem. Let's draw another picture here. Okay, let's say that we're in town, and we're flying our drone. And normally we can go clear out here in the desert, but when we get in town, we can only go this far, and it says, it's not saying I'm out of bananas. It's saying I don't have time to take care of all this junk. And what are we talking about when we talk about junk? All right, well, let's do this. Let's take this guy. And he transmits at 2.4 gigahertz, okay? Gigahertz. Now that is 2,4,000 million. Okay? He's transmitting at that many per second, all right? And so he does that. And this guy here, he can transmit at either, but he also he transmits at 5.8 gigahertz, okay, which is 2.4, let's see, yeah, this is more than twice as much as this. I never thought about that till now. So, because that's the way DJI set this up, okay? So, now, when I hook up this to my, let's say to my little glider, I got some videos on my glider, okay? When I hook this up to my glider, I have to bind them, okay? Now, in binding, let me go back in history a little bit. When I used to fly model airplanes many, many years ago, when you went to the flying field, they had a board over here with nails in it, and you had a little card that if you like belonged to a flying club, and you hung up your card, and it said that you were on 27.2 megahertz, okay? And another guy brings his in, and he's got one that's on 27.5 megahertz. And so he hangs his on a different nail, because these are all labeled for different airplanes that you have. Now, if another guy comes in who's on 27.5 megahertz, he hangs his card up on the same nail as this guy. Now, these guys had to agree, don't fly when I'm flying, okay? We'll take turns. If there's nobody with a 2.2, then he can fly all he wants. But that's how it used to be. Now, that's when we were using lower frequencies, okay? And I'm not sure if that was the frequency. I've probably forgotten by now. But anyway, that's when we were using lower frequencies. And lower frequencies can't carry as much information. Let me see. Do I still have? No, I don't have that. Okay. So if we're flying at 2.4 gigahertz, that means every second we're putting out that many pulses, okay? Now, supposing that we want to add some information to our pulses. So let's say in 1,000th of a pulse, which would be right there, okay? This is the whole pulse, and we're just going to use 1,000 to talk to our drone, okay? So what they do when I bind this to to my airplane, I'll make another picture here. When I bind this to my airplane, one of the pieces of let me go back. When you have such a high frequency, you can put altitude in, you can put speed in, you can put number of satellites in. You can put a whole lot more than that in that one little pulse in a fraction of a second, okay? Now, I'm making it too simple maybe, but anyway, you can just fill that pulse with all kinds of information. In fact, when you sit down to watch your Wi-Fi at home here in the United States, you're on most probably on 2.4 gigahertz, all right? And in that one pulse that comes in that part of a second, okay? You divide a second by that many pieces, okay? They can have every pixel on the screen of your television to tell it what color it is, what line it should be on, and so forth. So you can pack a whole bunch of different pieces of data into a signal in 1 second for that, okay? So with our DJI drones and our Parrot drones, all that information that you're getting back from the drone is transmitted in that one little pulse, and like altitude and so forth. Okay, so when one of the things that we need to do when I go to fly I have several model airplanes. So when I go to fly this model airplane, I need to bind the two together. So how are they binding each other? All right. So here's the transmitter. We'll make it right here. There's the transmitter. That's this guy here, and here's my little airplane. Okay. So we'll just draw a little airplane like that, tail, nose, and stuff. Okay. Now let's say that by the way, every transmitter made has its own binding code. All right. That way, we can go to the flying field now, fly on 2.4 gigahertz with this thing, and nobody else at the field, they're all going to be on 2.4 megahertz now, but each 2.4 megahertz transmitter has its own binding code. So these transmitters are not going to interfere. You don't have to have that board with the nails in it anymore, because there's no more interference at a high frequency where you can pack a whole TV picture into a pulse. Okay, so we can put the number that was assigned to this into a pulse. All right, so let's start out over here. So let's say that the pulse signature of this is a simple 1, 2, 3. Okay, so when you go to bind, you turn this one, with a model airplane, you turn this one on first, and you turn this one on first, then you turn this one on, and this one starts sending out, hey, my pulse is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And this guy is going through every possible frequency binding code that it can find, and it gets to 1, 2, 3, and then it pulses back, I got it. So then you're binding, it says, I'm all done binding, okay? And the same thing is true at the factory when they bind this transmitter to the drone that I have, okay? They did the same thing at the factory. So when I got it, I didn't have to do any binding, okay? But with model airplanes, you do. Okay, so now this one works on a binding code of 1, 2, 3. Plus, he's putting out his altitude and his temperature of his batteries and all the information that comes back down and is received right here is received on this guy, and it goes into my phone or whatever, and I store it, okay, for each second that goes by. So that's the binding code. Now let's say my neighbor, I've got my airplane bound, but let's say my neighbor, he has a drone. And by the way, this is on 2.4. We'll just use 2.4. And this one's on 2.4. Okay? They're both on the same frequency, at 2.4 gigahertz. And and he has a drone. So let's see. We'll just make a drone go like this with props. Here, 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 and here. Okay. And he has a drone. And these were bound at the factory. And their number was 4, 5, 6. Okay. So they're bound together, and their binding code is 456. Okay? So now when he turns on his transmitter, and I've got my transmitter on, even though we're close together and these guys are interfering with each other, it doesn't cause any interference, because what's going to happen when he turns his on and he starts getting this 456 thing, he says, I don't need that one because it's 456. And every time this pulses, he gets a pulse. Oh, don't need that one. But when he gets the pulse for the 1, 2, 3, he says, "What do I do? What do I do?" And he starts responding. Okay, so but my neighbor's is not. He's ignoring it. He's getting it, but he's not doing anything with it. Okay, and so that's how the 2.4 or the 5.8 gigahertz works. Now, the reason 2.4 works so poorly compared to 5.8 is because most homes, even though they do have the ability to use 5.8, most homes don't. And so that's why my Bebop drone, which only would operate on 2.4 gigahertz, would only get down to the end of the block, and then I would lose contact with it. Now, actually, I didn't lose contact with it because I took it way out into the desert where it was only getting a few pieces of banana, and it worked great. So what happened? Well, in town, he's got this house and 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 this house, and he's got 4, 5, 6, and he's got 7, 8, 9, he's got 10, 11, 12, he's got all the way down here, okay? And they all got their signals going. Their TVs are on and their routers on and everything. And so my poor little drone, he's going down here and he's getting all these signals at 2.4 gigahertz. And he has to assimilate every one. He has 7, 8, 9, don't need that one. 10, 11, 12, don't need that one. And so he's busy trying to get it out. And then finally he gets one of mine, like 4, 5, 6 or something like that. And he says, "Oh, what's that tell me?" And he listens. But as he gets further down and gets more and more Wi-Fi, he has to process every one of those Wi-Fi signals. And so in town, pretty soon he says, "I'm getting too many of these things. I can't keep up." And so you say, "Well, I'm losing contact." No, he's still in contact. He just can't keep up with all the information he's receiving. It's kind of like when I was in school in biology class. I didn't do too good because there was too many names to manage, and a few other classes too, but we won't go there. Anyway, so that's why when you're in a high Wi-Fi area, the signals are not causing the problem. A high level of signal is, that's fine. It's not going to bother anything. But out in the desert, these guys are miles away, and so it's like finally I'm not getting any of their bananas, or if I'm getting any bananas, it's not much at all. But out in the desert, I don't have any interference from the Wi-Fi binding numbers, or whatever you want to call them, codes. So I don't. These guys in town, oh yeah, I got to process each one and see if it's for me. But out in the desert, I don't have to process each one. And so I can go a lot further until finally I run out of bananas, okay? Now, if you have comments or questions, I appreciate hearing about them. And I hope this has been helpful. I know, I'm full of bananas. Actually, I can't eat bananas because ever since I was a little kid, they made me vomit. But anyway, that's pretty much a basic, quick rundown of how come our transmitters seem to lose contact around a high Wi-Fi area, and how come they go to work just fine out in the desert. And that's why 5.8 and 2.4 have different results also. Well, I hope that's been helpful, and thank you for putting up with me, and God bless.